Okay, so we just went over an efficient two-dimensional data distribution for dense matrix vector multiplication, which made use of collective communication routines on top of subsets of the processes. In particular, we thought of taking a grid of, say, 16 processes and arranging them into a 4x4 grid, which you can see drawn on the board. So suppose that we organize the processes into this grid based upon their rank in a column major fashion. So in particular, we think of starting in the top left, putting process 0 there, and then working our way down, and then starting again at the next column. So what we want to do then is find a way to construct communicators for each process that consist of its row of processes and another communicator for its column of processes, because we're going to respectively perform an MPI reduced scatter within the row communicator and an MPI all gather within the column communicator. So one way to do that is to make use of the routine MPI Comm Split. So what this routine does is it takes in a different color from each process and a different key from each process. And these are, in particular, integers. And so if we wanted to create a different row communicator, or 4 different sets of row communicators, then what we would do is we would have each process pass in that wants to be in the same row communicator the same color. So a natural choice of that would be the color 0 for this row, and then the color 1 for this row, etc. So processes 0, 4, 8, and 12 would each choose the color 0. Processes 1, 5, 9, and 13 would choose the color 1, etc. Okay, so after we've grouped processes together by their colors, we then have to choose, well, what is their rank within that subcommunicator? So if we thought of organizing processes 0, 4, 8, and 12 into a row communicator, it would be natural to have process 0 be rank 0 and process 4 be rank 1, etc. So what we want to do in this case to construct row communicators is to choose the color equal to the row index and then the key equal to the column index. So in particular, to do that, we could simply choose the color equal to rank mod 4, and then the key equal to rank divided by 4 in integer arithmetic. Okay, and so then what that would produce is a row communicator. So each row of processes in this case would be in the same communicator. And so likewise, if we wanted to construct different communicators for each column of processes, then we would simply replace or switch the modulus operator with the integer division. And then we can construct column communicators. So once we've constructed these, say starting with MPI Comm World as the original input, then we can call collective communication routines on these subsets of processes. So this is really the last thing that was needed that we hadn't introduced so far. So in summary, you could take MPI Comm World if it had, say, 16 processes, conceptually arrange it into this two-dimensional grid, and then think of how to organize into different subsets of processes, in particular into teams of the rows and then teams of the columns. And then we can create those communicators using this routine MPI Comm Split.